Okay, now let's go to the next one, next packet. I'm gonna come back to this one. This is not a good problem to start with. Okay, I'm doing this. Now this is new. You haven't done this before. Okay, it's similar, same setup as yesterday, but then the equation ends up differently. A bank account contains $5,000. It earns 3% interest each year. How many years will it take the account to reach $6,000? So this time I'm finding the years instead of the new amount. Setup's the same. Okay, X is years, Y is money. Dollars per year. It's not a dollars per year, it's a 3% interest. Interest always add 3%. Okay. Now, rewrite your 3% as a decimal. Plus 0.03. So this is a growth rate, okay, because it goes up. So with these so it's an exponential function. So it's blank times blank equals blank. Put the exponent there. So I have the original, and that's your Y unit. And then your percent. Your power is the X unit. And then the new, which is also my Y unit. Okay, now we fill this out. So the original is $5,000. The percent, you have to take one whole and add 0.03. You can't just put 0.03. Okay, so 1.03. Then the years. Okay, I don't have the years because that's the answer to the problem. So I replace that instead of with a number, I replace it with the X variable because X is years. Now, if that's X, I better know what my new amount is. Well, my new amount's $6,000. Now, obviously the X has a lot of operations happening to it. So we need to clean this up. We can't just go to our calculator and plug it in. You need to write 5,000 multiplied by 1.03 and put the little X up here equals 6,000. Now the variable I'm solving for X is a power, okay? It's part of the exponents in the power. So what I do is I make my caret, then I circle and split, and then I'm going to set the power equal to the log divided by log equation. Now the bottom we know it's 1.03. The top I do not know yet. It's not 6,000 because what about the 5,000 that's being multiplied by the power? We need to undo the multiplication. I have a lot of goose that subtract this. No. Divide by 5,000 and divide 6,000 by 5,000. That tells you what goes in the numerator. So 6,000 divided by 5,000 is 1.2. Okay, if I calculate that, I have my answer for the years. So log 1.2 divided by log 1.03. Remember to close parentheses. It's about 6 years. Okay, so I'm going to just put it's over 6 years, so I'm going to put greater than 6 years. You can just put 6 too if you want. I don't care. Okay, example 2. In the year 2000, the average price of a football ticket was $50. The ticket is increasing at an average rate of 6% per year. How many years does it take the football ticket to reach a price of $75? Okay, so I've got dollars and years. Years being X, dollars being the Y, so per year. Dollars per year. There's no dollars per year, okay? It's a percent per year, and it's increasing, so plus 6%. Then right away rewrite that as plus 0.06. Okay, so this is, again, exponential growth function is not a linear equation. Okay, so that's why I'm going to set this up completely different. Blank times blank equals blank. Need a power in that second factor. So this is the original, and that's your Y unit. This is your percent, and then the power is your X unit because it's happening every year. Okay, and then here we have our new and that's also your Y unit. So the original amount is $50. Okay, now your percent, you have to take one whole and add 0.06 to it. You write 0.06, you're screwed. It's got to be 1.06. Okay, years, again, I don't know. Okay, and you don't put 2000. You don't put the actual name of the year. So again, this then becomes a variable, which is X. Okay, now my new quantity is $75. Okay, now you got to do more than just plug into your calculator here. So rewrite that equation. You got 50 multiplied by 1.06 to the X power. I'll put the caret there. You can put that there. Equals 75. Now where's your variable? It's in the power. So circle the power and split it. And we're going to solve this by using X equals log. Okay, now the base goes in the denominator, 1.06. Now the numerator, I don't know because I have to undo the multiplication of 50. And you do that by division, not subtraction. A lot of people subtract. Okay, quit it. 1.5. Okay, now plug that in. So log 1.5 divided by log 1.06. So it's about 7 years, okay? You can put less than 7 or just 7. Okay, I think one more example ought to do it. A new car is purchased for $16,000. The car declines in value by 10% each year. Find how many years it takes a car to get down to $5,000. Okay, so again, I've got dollars and I've got years. So per year. Okay, dollars per year, it's going down, so minus 10%. Okay, now 10% is double digits, so it's going to be minus 0.10. Okay. Okay, now this is a decay. Okay, so the setup's still the same though. You got your original Y unit, original money, and then the percent factor, and the exponent's my years, okay? Then you got your new right there. Okay, original cost about 16,000. Now my percent factor, okay? You got to take one whole and minus 0.10. Okay, this time you're minusing because it's going down. Okay, 0.9. Okay, you can't just, again, you have to take the one whole and either add or minus the percent decimal. Okay, the years again are unknown, so that is an X variable, and then the new amount is 5,000. Okay, so again, rewrite that equation. You have 16,000 multiplied by 0.9 to the X power equals 5,000. So now we're solving for X, and I see right away X is a part of the power. Okay, so circle the base and the power, split it, and then we can set that power equal to the log ratio. On story problems, I go right to log over log. I don't mess around trying to. So 0.9 in denominator. Numerator, I don't know. I'm going to have to divide both sides by $16,000. Okay, so 5,000 divided by 16,000, 0.3125. Okay, now I calculate my answer. Log 0.3125 divided by log 0.9. Okay, about 11. Okay.